Hey everybody, I just wanted to remind you a little bit about acids and bases. This is what we've been talking about before the break. Acids and bases. Well, let's talk about their properties first, because that's in the ancient times, that's how you identified them. Remember, acids have a little bit of a sour taste to them usually. Think vinegar, think lemon juice, even orange juice without sugar. How it has a little bit of a sour taste to it. Also think in terms of acids react with metals, this chemical property. Acids react with metals to produce hydrogen, but each acid doesn't react with each metal, though many acids do react with several different metals. Take, for example, copper. Copper only reacts with nitric acid, but it doesn't really react strongly with sulfuric acid, for example. And bases are kind of the opposite. Bases are a bitter flavor. They tend to have kind of a slippery feel to them. Think about like soap, for example, as a base. And when they come into contact with acids, they neutralize those acids. Now, why are acids and bases important? Well, it's because so many of the things around us are acids and bases. You yourselves, your proteins are made of amino acids. Your DNA, the biomolecule that stores your genetic material, stands for deoxyribonucleic acid. But within those acids, we also have bases. For example, the nucleotides or the nuclear bases that make up our DNA are in fact weak bases. Many of the things that we take into our body are acids or bases, or acids usually. For example, food dyes. Most food dyes are acids, very weak acids, but acids nonetheless. And a lot of your milk is slightly acidic. Your salad dressing is maybe based on vinegar. Ketchup, mustard, mayonnaise all contain vinegar, so no surprise they're a little bit of acidic. Meanwhile, a lot of cleaning supplies are basic. For example, ammonia, for example, soap, bleach, oven cleaner is a very strong base. So acids and bases are all around us. But what are they? I've described them, I've given examples, but what are they? Well, simply put, and this isn't very simple, but an acid is a compound that in a solution donates a proton or a hydrogen atom to that solution. It gets picked up by the water molecule, and so an acid is a proton donor, which means a base is a proton receiver. In the case of a strong acid, what happens is that it donates this hydrogen ion, it donates this proton, and the water picks it up and forms kind of a negatively charged water. But then later, that water may give that proton to a base, to a stronger base. The reality is that water is both an acid and a base. It's one of the few substances that can pull this off. But it is the proton receivers that are our bases. There's actually a short video that I'd like you to watch from our friends over at TED on acids and bases that has all sorts of muscle pumping acids and muscle pumping bases. And so you get a really good idea of what they do. Also this week, there's another video I want you to watch. There's some other activity on how acids and bases work, and how ammonia, being a weak base, is such a good cleaner, and why that is the case, and why it'll clean up, for example, old hamburger grease. And so I've also got a couple things for you. I've got a reading science. I've got a web surfing science on some of these videos, and so really want you to encourage you to keep up with all of these things. Everything will be due on Friday at noon. Now, how do you turn all this stuff in? Well, to turn it all in, what I need you to do is you can either complete it and then submit that to me via email, or you can print it out, complete it, take a picture of it, and then submit that picture to me through email. As a reminder, my email is rpresley@esc17.net. So all of these are great. I know these are kind of unusual times. This is not how I would normally choose to be having this conversation, but it is the situation that we are in. And so we're going to make the best of it. The nice thing is that instead of sitting in my class for 45 minutes at a specific time, you can actually go in a backyard, much like I have, and you can do your chemistry in the sun, in the daylight, in daylight. Or if you're a night person, you could be at 3 o'clock in the morning, although I don't recommend it, 3 o'clock in the morning doing this, as long as it all gets done before noon on Friday of this week. All right, I've got another video I want to talk to you about weak acids versus weak bases, but that'll be a different video. All right, until then, stay safe, stay well.